Welcome to video 2-3 for Chemistry 1, dealing with atoms and subatomic particles. If you have not already, grab your periodic table of elements and get it out. The one I gave you in class, that's in your binder. We'll be using that in this lesson. So this lesson is going to help you determine how many protons, neutrons, and electrons an atom has, based on the information given to you. So the primary source of information you're going to get is going to be your periodic table. But we're going to use that periodic table and other forms of information to come up with the protons, neutrons, and electrons. It's as easy as adding and subtracting. Here's some vocab terms. So again, at any time, pause the video, search this word if you feel like you don't understand it well enough in the way I use it within a sentence. But these will be defined or explained as we go through here. So we talk about atoms. We know an atom is a cluster of protons, neutrons, and electrons. So when we say the word subatomic particles, we're talking about an individual proton, individual neutron, and individual electron. So when you see the word subatomic, you can think of the word submarine, where it goes under the water. Subatomic means you go inside the atom. What's going on inside the atom? And that's where the protons, neutrons, and electrons are going. So right here, we've already seen in the last video that all atoms are not the same. That is why we have 118 different elements, because those elements are made of different atoms, and those atoms are different. So what is it that makes those atoms different? The number one thing that makes those atoms different is the number of protons. Let me say that again. The number of protons is how each element is classified. So if I'm walking through the woods and I see a cluster of 3 protons stuck together, I can walk by that element in the woods and say, yo, what's up, Mr. Lithium? Or if I'm walking in the woods and I see a cluster of 2 protons stuck together, and if I have my periodic table, if I have this memorized, I can say, hey, that is helium over there. So we identify different atoms or elements based on their number of protons. This number is called the atomic number. So the atomic number is simply the number of protons, and that's how we identify. And that is the fundamental reason why each element is that element and why it behaves the way it behaves. So this atomic number will always be equal to the number of protons, and it will always be a whole number on the periodic table. So as I pull out my periodic table here, we can look down here in the bottom, and on the periodic table I gave you, the top left here is where it says atomic number. And so zinc is zinc, because that atom has a cluster of 30 protons together in the nucleus. Now look at helium, he has the 2, so helium has 2 protons. Boron has 5 protons. Oxygen has 8 protons. Fluorine has the atomic number 9, therefore it has 9 protons. So now, we can see that even though every atom has the same number of protons, it can have a different number of neutrons and a different number of electrons. Let me say it again. Every atom, if it's the same atom or if it's the same element, if every element is the same element, it must have the same number of protons. However, different elements could have different number of neutrons and different number of electrons. So look at carbon here. Carbon has 6 protons. I can see that on my periodic table by looking at the atomic number. So the fact that there's a cluster of 6 protons here, we get to call these guys carbon. But I can change the number of neutrons, and I can even change the number of electrons. When we change the number of neutrons, when an atom has different number of neutrons, those are called isotopes. So these are 3 different isotopes of carbon, or this is a carbon-13 isotope, and this is the carbon-14 isotope. So when I look at this, what makes them isotopes? Well, the fact that this has 6 neutrons, 7 neutrons, and 8 neutrons. The fact that they have 6 protons tells me these guys are all carbon, but the fact that they have different neutrons means they're isotopes. And right here you can see the hyphen notation, which we'll learn about in a second, where you basically put the mass, the total of the protons and neutrons, behind the name. So look at lithium. Lithium, typically on your periodic table, would have 4 neutrons, but lithium could also have 3 neutrons. And so when you look at your periodic table, and I'll pull it up real quick, let's look at lithium. So here's lithium right here. You see the number is 6.9. In this class, if you ever get a mass off of this periodic table, go ahead and round it to 2 decimal places. So we're going to take that 6.9 and call that 7.00, or 7 for right now. And so it has the atomic mass of 7. So since there's 3 protons, he also has 4 neutrons to get to that number 7, which we'll cover here in a minute. But sometimes lithium can have 3 protons, and that's why this number is not exactly 7, because it's the average of all the lithiums that exist in the world. And so sometimes lithium has 3 protons and 3 neutrons, and therefore that would be called lithium-6, where here the most common isotope we find is a lithium-7. So again, these are different isotopes. They're the same element because they have the same number of protons, but they're called isotopes because they have different neutrons. So how do we write it? How do we write these different ways to show what's going on and what isotope we're talking about? Well, there's 2 symbols you are learning right now. You are learning what's called the hyphen notation, which is simply where you write the word with a hyphen and then the number for the atomic or for the mass, and then the nuclear symbol, where you will write the element symbol, but then the mass number on the top and the atomic number on the bottom left. So remember, the atomic number is just the protons. The mass number, however, is the mass of that element. So here, a mass number is the number of protons and the neutrons. So again, on your periodic table, you can find that. Down here in the key, we see it's called atomic weight, but we're also going to call that atomic mass. So atomic weight and atomic mass are interchangeable since we're on planet Earth. And so again, when I look at lithium, it says 6.94. So that is the atomic mass of lithium at 6.94. But when you have a chance and I ask you a question, you just need to round that up to 7. If I ask you a very generic question about how many protons does lithium have in general. But sometimes we're not talking about lithium-7. Sometimes we're talking about lithium-6. Or sometimes I'm not talking about helium with 2 protons and 2 neutrons. Sometimes I'm talking about a different version of helium, and that's why we would write it like this. So if I wrote helium-5, or helium with a 5 over a 2, then it means we're talking about the element helium, but we're talking about when it has 3 neutrons along with those 2 protons. So don't overcomplicate it. It's a really simple idea. Mass number is just the number of neutrons plus the number of protons. That gives me the mass number. So essentially, it's the mass of the nucleus. And the electrons are so small and so light that they don't even affect the overall mass. And again, when you're getting a mass off of the periodic table, just go to 2 decimal places. So now what about electrons? What happens when I change out the electrons? Well, if an atom is neutral, then we're going to say that the electrons are equal to the number of protons. So for example, if I have bromine, and if bromine has 35 protons, it automatically would have 36 or 35 electrons. So go back to my periodic table. If I look here and I see helium, if helium was neutral, we would say automatically, based off of this information, helium has 2 protons for the atomic number, and I would say he has also 2 electrons because every element on here is considered to be neutral. Now, when they start gaining or losing electrons is when we get into what's called ions. So again, if it's a neutral atom, the atomic number will also be not just the protons, but also the electrons. But if it creates an ion is just when an element or an atom has gained or lost an electron. Now we have an ion of bromine and not the atom of bromine. Let me say that again. This is called the ion of bromine because it has a different number of electrons than protons. If I took away this negative sign, then that's how we would show just the atom of bromine. So what does this mean? Well, this charge indicates we either gained or lost an electron. Now remember, electrons have a negative charge. So the fact that I have 1 more electron than a proton, I have an extra negative charge. The opposite is true as well. If I have 2 less electrons, or if I have 2 more protons, then the charge on calcium will be +2. So again, why is this calcium +2? Because in this ion, calcium has 20 protons and only 18 electrons. 20 minus 2 gives me a +2. Here, bromine is a negative charge because it has 35 positive protons, And when I compare that to the 36 negative electrons, I have one extra negative charge, and therefore it's bromine with a negative. So let's practice this stuff. Again, we're just adding and subtracting, but we got to be careful what we're doing and form good habits so we don't get confused when we're adding and subtracting these different numbers. So problem number 1. How many protons, neutrons, and electrons are found in the atom of iron 58? So a few things you should begin to recognize. First of all, this is written in hyphen notation. It gives me the name iron, so I know what element I'm talking about, and it gives me the number 58, which again, from the previous slide, you should know that that is the mass number. So 58, right now off your bat, you should know that is the number of protons and neutrons that this iron has. So the first question would be well, how do I find out how many protons does this iron have? Well, if I go back and look at my periodic table, I can find iron right here, and it says 26. So as I look at my periodic table, I see iron has the atomic number 26, so I automatically know it's very easy. I just use my big cheat sheet and I write down the periodic table number is 26. Therefore, I have 26 protons. 26 protons. So now, since the mass number is 58, I have to come up with a number of neutrons based on that mass number. So in order to find the number of neutrons, let's get rid of that. Put that there instead. In order to get rid of that, or in order to come up with the number of neutrons, I have to take and do a little math. I have 26 protons. I need to find out this unknown value of neutrons, and whatever that number is, it needs to add up to 58. So all I do is simply take 58 minus 26, and I come up with 32 neutrons. So again, the neutrons is just 32. And then again, I look at the electrons. Since there's no charge here, it doesn't say anything about the ions. The number of electrons will equal the number of protons. So the way we would write this to keep it nice and clean, so I know what you're talking about and how to label it, we're going to say the protons, or the P equals 26, the N equals 32, that's the neutrons, and the E equals 26. So now it's your turn. Here are 2 practice problems for you to try. Go ahead and pause the video, try the first one, I'll explain the first one, and then pause the video, try the second one. All right, so how do I do the first problem? Well, first of all, we're going to read it. It's simply going to say how many protons, neutrons, and electrons are found in the atom of bromine 79. So right away, I see bromine, and I can look on my periodic table, and I can say, okay, bromine, right away, I know has an atomic number of 35, so therefore, bromine has 35 protons. That's the atomic number. So therefore, my protons equals 35. Easy, right? So now, my neutrons. I know that the neutrons are the protons plus the neutrons equaling the atomic mass. The atomic mass here is 79. That's why it's written like this in hyphen notation. So I simply need to go back and solve for N. I know the protons are 35, so all I need to do now is solve for N, and with a little math, you realize N is going to be 44. 35 plus 44 equals 79. So now I would say my N is 44. And then for the last part, how many electrons do I have? Well, there says nothing about ions. There's nothing about a charge. There's no negative sign. There's no positive sign here. So I automatically know then that the number of electrons is going to be the same as my protons, and therefore there are 35 electrons. Now pause the video and see if you can answer this question by yourself with looking through the notes and trying it. So now as I look at the second part of this practice problem, it says write the hyphen notation, which is going to look like this, and write the nuclear symbol, which if you remember from the slide before, you're going to use the symbol, put the mass number, and the atomic number. So how do we do it? Well, the hyphen notation for the isotope of 28 electrons, 32 neutrons, and 26 protons. So first of all, I need to find out what's the name of this isotope. Well, we know that the names are determined by the number of protons. So I get out my periodic table and I say, okay, what has the atomic number of 26? And I find it's iron. So I'm going to write down iron. And then now, to finish my hyphen notation, I have to put the mass here. The mass came from the number of protons and neutrons. So I see I have 32 neutrons. I'm going to add that to 26 protons. And that is going to give me a total of 58. So to write my hyphen notation, I would simply write iron-58. Pretty easy. Now I need to check for the nuclear symbol. Well, if you think back, the nuclear symbol is when you put down the symbol for the element. You put the atomic mass in the top left corner. You put the atomic number in the bottom left corner. So number of protons. This is the number of protons and neutrons. But we're missing one other thing. We're missing if there's a charge or not. So I need to go back and check the electrons compared to the protons. And I see that there are 28 negative electrons compared to 26 positive protons. So there's two different ways you can do this. The way I'm going to show you is just going to do it 28 negative plus your 26. Since that's going to be left over with a negative 2, you're going to have a negative 2 charge up here. Meaning that there are 2 more electrons than protons. 2 more electrons than protons. And that's why we would write negative 2. The other way you can do it is you could just, again, intrinsically think about it. You can see that there's 2 more electrons than protons, so therefore I would have a negative 2 up here. So you can show your math this way if you would like, by just making your electrons have a negative value, your protons positive value, and then whatever the difference is goes up here. Or you can just look at it and say, okay, electrons versus protons, I can do that in my head. All right, I hope you're finding this stuff pretty simple. Once you practice a few times, I feel confident that you will master it. But that's why we have the lesson that you can read through and can practice in your notes. So again, long story short, the number of protons in an atom is equal to the atomic number. So you look at the periodic table, the atomic number is the number of protons, and that's what determines why an element is that kind of element and why it behaves that way. The number of neutrons can differ. We call those isotopes. So protons might change the element. Neutrons don't change the element, it just changes the mass number. So remember, you can find and calculate any mass number by just simply adding the protons and the neutrons. Or vice versa. If I'm given the mass number and the number of protons, I can easily calculate the number of neutrons by just subtracting. And then the number of electrons can change as well, depending on the charge of the atom, depending on whether electrons are coming or going, being added or subtracted. I hope this has given you a good start to the subatomic particles. I'll see you in class.